Hello, I'm Bob Allison, WB1GCM from the ARRL laboratory here in San Jose, California at the AMSAT Symposium. I'm here with Gould Smith, WA4SXM. Gould, thank you very much for being here with this interview.
Glad to be here, Bob.
And I understand you're a project manager for this big ARROSAT satellite that was recently released from the space station.
Yes, I am.
Well, before we go into that, I'm just going to ask some standard questions about how you got involved with amateur radio. How did you find out about ham radio?
My father was an amateur radio operator in the 20s.
1920s.
And then lost his call during the war. And then he picked it up once he got back, and hours and hours of listening to a CW tape and getting back his code speed, and he loved working 6 meters and looking for openings, and I was kind of fascinated with it, but not enough to pursue it at that time.
I see, yeah.
And later when I was in college, actually 2 or 3 of my friends were into it, so I got into it because of them, more or less. And
That's good. And what year were you first licensed?
in 1976.
1976. Very good. Now, how did you get interested in amateur satellites? What spurred your interest?
I'd always had an interest in it, but I was under the opinion it was very expensive to get into, and a 2-meter radio was a big expense for me at the time, and
Understandably.
and so it was something I was very interested in, but didn't think I had the resources to pursue at the time. And in 1988, they had the AMSAT Symposium in Atlanta, which is about a 4-hour drive for me. And I went down there. That was the time they made the first contact with the people in Mir. And Leo,
Yes.
and I was there, plus everyone that I'd read about in AMSAT International was there, and you'd sit next to in the meeting, and found out that there were a lot of economical ways to do that, so went home and started pursuing it. And so as my interest and responsibilities have grown, I make it a point right up front that it's not an expensive part of the hobby. Just like any other hobby, you can buy top-notch equipment and spend a lot of money, but there are many alternatives to get you active and fully functional for a very modest outlay.
Indeed. Plus, many people have the ability to homebrew, let's say, a satellite antenna.
Oh,
That's
certainly.
something you don't have to go out and
from
buy.
Home Depot, you can
Certainly.
get the components. So.
And here in front of us is the ARROSAT, and it's made out of various components. You can explain that a little bit more, Gould. But you were the project manager. How did you become project manager of this particular satellite project?
Truth be told, I was a little frustrated with the slow progress, and I was AMSAT officer at the time, so I wasn't completely unknown. So I volunteered to help get this back on track, and I'd had a fair amount of project management experience. So that's essentially where the problems were. They're just typical lack of communication.
And it's all volunteers, too.
Right.
Volunteers that build this entirely, and a lot of contributions.
So, and it essentially boiled down to getting people to talk to one another and work together, and just, set up weekly meetings. And now, it was still SuitSat at that time, where most of these modules were going inside a used Orlon suit.
I remember the first one. That was really spooky as it went away.
And it grabbed the world's attention, too.
Yes.
And as soon as this became your standard satellite form factor, it lost a lot of its wow factor, even though the electronics and everything were the same.
It's packed full of things.
So, and the reason it's so large, this would be extraordinarily expensive to physically get this up into space, but the Russians allowed us a very generous mass upmast to the International Space Station. NASA had donated the solar panels, so we designed the structure around the solar panels so we could put 6 of them on the 6 sides of the satellite.
So this actually was brought up on a Soyuz rocket.
On a Progress.
On a Progress rocket.
Progress.
On a Progress rocket.
Progress,
okay.
they carry, water, food.
Yeah, that's right. It's a big cargo
Just cargo.
capsule, yeah.
Right, just cargo.
Very interesting. Gould, could you explain actually, well, what's inside of all this, and maybe do a little bit of a walk around? I see some switches up here.
Okay.
I know what this is the antenna.
A 2-meter antenna, correct.
Yeah, and there's a
And I don't know whether you can see it, but there's
down here.
a little 70-centimeter
Hi, down there.
antenna under
Right
the
here.
bottom.
Yep.
There are 3 switches here with switch guards, and there's enough room between them so that the astronauts, cosmonauts can actually get their glove in there, but only control 1 switch at a time.
That's what the guards are for,
That's
sure.
what the guards are for.
Yeah.
So there's a power switch, and then there are 2 timers. And NASA required us to have a delay of 15 minutes once we turn the power on and the timers until the satellite transmitted, just to prevent any interference with the cosmonauts in the spacesuits.
Oh,
and
certainly, a little bit of overload there, for a strong
right.
signal overload, yes? Mm-hmm.
So, not that they experienced it, it just erring on the side of safety.
Caution,
So,
certainly.
Right, so.
Yep.
The large vertical cylinder is a Russian experiment from Kursk State University.
This is it right here.
That's it right
Yep.
there. And it's made to measure the vacuum in space, so
Oh.
how many particles there are. So the gist of the experiment was to categorize, but to measure this as the satellite spins into the Earth. So they can
Yeah,
see how
there is drag up there, so there is air. It's not a
I mean, it's pretty far
total
apart,
vacuum,
but
yes.
the closer you get, but apparently that hadn't been measured in a long time.
Oh.
So this was going to be a good scientific experiment.
I see.
There's a little mirror over here that we have
This one here?
4 off-the-shelf security cameras that we've mounted in here. And then we take that live video image and digitize it into a single frame and then convert it to Robot 36 slow-scan TV format. These large Lexan panels are just to protect the solar panels that are under them. Initially, these large T-pins were so that the cosmonauts in their gloves during the spacewalk could get their fingers under here
Yes.
and pull the pins off and take the protective covers off the solar panels. The
yes.
Russians didn't want to spend as much time outside on this particular mission, so these were taken off inside, and the Russians provided some quilt-like covers to cover the solar panels, and those were taken off outside. And
I learned something a little interesting about the solar panels themselves. They go on the sides and the front and all sides here. Now, the solar panels, what were they held on by?
that was
Explain
we had looked at a number of different things, and when we attached the solar panels to the back plate and cured the epoxy, it was a temperature coefficient differential that caused the back plate to bow a little bit.
Ooh.
So we had to come up with something else, and we didn't have but 1 extra solar panel to deal
Right.
with. So Lou McFadden came up with the idea to use Velcro on the solar panel and the chassis, and it turned out to be a marvelous
Low-tech
creative
solution.
decision. And it gave us access to the inside easily. It for the 90 days it's been in space, it's proven to work extraordinarily well. We'll see over time
Yes.
how that'll work with elemental oxygen and whether, but it's all part of the experiment. If it works well, we've found a nice, cheap solution.
The very,
And,
yeah.
when we told NASA that's what we were going to do, the room got really quiet because people couldn't find a problem with it, but then they were saying, that's such a good, simple solution, and it may work, but nobody knows. So it's those creative moments that are always fun when you come up with a good idea, and it seems to work.
Excellent. And I see a whole bunch of boxes inside. So what does this actually do?
All right. We have a number of functions. This was commissioned by ARRL, which is Amateur Radio on the International Space Station. It's an international group. And one thing that they really wanted was to enhance STEM education. So we tried to put a number of things that we thought schools would gravitate toward, so that they could use this in their curriculum or class session to see. So we have a voice ID that a simple 2-meter handheld radio can copy. We have about 6 telemetry values: the temperature, the battery voltage, the battery current, so you can get temperature inside and outside, and that's spoken so that you can listen into that and actually chart how the battery changes. Impressive. Or what the temperatures are. Then we have 24 different voice greetings from children around the world in 15 different languages, so they can listen. And most of those have a secret word. So the children can listen to the audio, hear the secret word, and send it in and get a certificate.
Nice. And
then we have the 4 cameras that take slow scan TV pictures. Those are transmitted on the 2-meter downlink. And then that cycles back through.
I can't wait to get home and look for this. This is great.
One of the innovations is there's a software-defined transponder. And so we have 40 kilohertz of bandwidth on 2 meters that we're constantly transmitting. So there's simultaneously an FM signal, a 16 kilohertz transponder, a CW signal, and a BPSK signal.
Wow.
That's a new protocol that Phil Karn came up with, so that we should be able to pull telemetry data out of the noise. It's he's been doing that kind of work for cell phone technology for years, and he specifically wrote this for this satellite, but for future satellites to be able to be with a good bit of forward error correction, so that you can pull a completely valid packet of data with almost no signal to noise ratio. So, and that's working extremely well. We also had volunteers that wrote ground station software, so you could plug your sideband radio audio output into your computer sound card, and it would completely demodulate and display the data and store it into files. In addition to that, the software would automatically send it into a central server, and over 160 countries in the world have sent in data to the server.
Excellent. My goodness, so it does an awful lot. And question about, there is a battery that goes in this.
Yes, the Russians' Orlan spacesuit battery is a silver zinc technology, and initially we thought we were just going to get one of the old ones, but they commissioned a brand new one from scratch, and the problem with that is that those batteries and that silver zinc technology are designed to give you a constant voltage for a long time and then essentially drop off.
Oh.
So the problem is that they're good for 5 charge-discharge cycles. So in something that every 90 minutes goes through a charge-discharge cycle, that's not a great match. And as it turns out, the battery lasted about 10 days in space. So we had designed the satellite so it would run on the solar panels also. So currently we're only active when the satellite's in sun.
Okay.
And
keep that in mind. And what's the life expectancy, do you suppose?
Right now, we're looking at the latest numbers. It'll probably go into spring before it deorbits.
Very good. But this is a lot of components in here. It's packed full of things.
Well, there's actually a huge amount of free space because we had to design it to fit the solar panel.
Yes.
So on the next one, we built 4 of these. And,
you have.
This was going to be a continuing project with NASA. So we're able to put more experiments inside with the free space.
Excellent.
And the Russians are the only ones that completed an experiment in time for this mission, but in future missions we have room to put additional student experiments. And the experiment data alternates with the telemetry data, so you get one packet and one packet. And
Very
so-
good. Well, it looks like we have a lot to look forward to with amateur satellites and Gould. Just amazing work that you've done. This is a marvelous piece of engineering. Congratulations on it. And thank you for all the work that you do on behalf of amateur radio.
Well, thank you very much.
It's a great
It was
contribution. It's great for the kids to get involved in the classroom, and they can pick this up and be involved with space communications. This is something that's truly will get young people involved in our hobby. So, Gould Smith, WA4SXM, thank you very much for joining me
Thank
here
you,
today.
Don. Enjoyed talking to you.
Appreciate all you've done. Thank you.
Thank you.